Hello everyone, welcome to this video. In this video, we're going to look at this problem from the entrance examination from CMI 2018. And we are asked basically to list the possible real solutions of this equation, cube root of x plus 4 minus cube root of x equals to 1, where x is a real number. Okay, so to solve this kind of problems, you might have seen these problems a lot where there is cube root of some variable and you multiply it from another cube root and then the answer is some integer. So in this kind of problems, it's very necessary to assume something which makes you get rid of this cube root. Okay, that is the technique that what we are going to use here. We will assume x plus 4 as a cube and x as b. I could have done only one variable here, but let's take a and b both because that is going to be relatively simpler, at least to work with, right? So this gives us obviously cube root of x plus 4 equals to a. Well, the cube root of x plus 4 here obviously has two other values, which is a omega and a omega square. But remember that we are only dealing with real values and not complex values here. And again, cube root of x should be b, where obviously a and b are both real numbers. Now, with this substitutions in hand, our equation actually turns, the first equation turns as follows: a minus b equals to 1. This is our first equation. And we have another equation because since you know a cube minus b cube is also an integer here because x plus 4 minus x is 4. So a cube minus b cube should be 4, right? This is our second equation. Now, from the first equation, from 1, we get a is equal to b plus 1. This is our first equation and this is what we get. And if we put b in the second equation, first of all, we'll put it after a bit of modification to it. So let's apply the formula of a cube minus b cube, which is a minus b whole into a square plus ab plus b square equals to 4. And since we know a minus b is 1, let's put in the value of a minus b. And we will get a square plus ab plus b square equals to 4. And now for a, substitute b plus 1. This will give you b plus 1 whole square. And then this a will also become a b plus 1 multiplied by a b, then also a b square equals to 4. This will get you b square plus 2b plus 1 b square plus b square equals to 4. Okay, now we can count. There are 3 b squares, so 3b square. Then there are 3 b's, so plus 3b. This 1 and this 4 gets cancelled off to become a 3. So we can bring that 3 as well to the left hand side. It becomes 3b square plus 3b minus 3 equals to 0. Or b square plus b minus 1 equals to 0. From the quadratic formula, this is simply equal to minus b plus minus root over b square minus 4ac, where you can understand what the coefficients a, b, c are divided by 2a. And this will simply give you minus 1 plus minus root 5 by 2. So there are two values of b here. So we'll take one by one. And for each value of b, we'll get a value of x. Now, remember from the initial substitution that b is cube root of x, that is x is basically b cube. So the first value of x is the first value of b whole cube. The first value of b, let's take the positive sign, root 5 minus 1 divided by 2 whole cube. So this becomes 1 upon 8, the cube root of the cube of 2 into, now a minus b whole cube is simply a cube. So root 5 whole cube minus b cube, which is 1 cube, minus 3 into a into b whole into a minus b. Let's simplify this further and we shall get 1 upon 8. Cube root of 5 is simply 5 root 5 because we multiply 3 copies of root 5 here, minus 1, minus 3 root 5 into root 5 should be 15, and minus 3 root 5 into minus 1 should be plus 3 root 5. And if you count there, that is basically 1 upon 8, 8 root 5 minus 16. Obviously, the 8 gets cancelled and you get the answer as root 5 minus. So that is our first value of x1. For the second value of x, x2, we will need b2 whole cube. And b2 will be simply getting, we'll simply get it by taking the minus sign here, which is minus 1 minus root 5 by 2. It can be done in a similar manner. And if you finish doing this, you will simply get the answer as minus root 5 minus 2. So the two real value solutions of this equation are respectively minus 2 plus minus root 5. These are the two solutions of this equation. So this was a fairly simple problem, but it's very useful to assume these values and substitutions before proceeding to do them, because doing it in a single variable might have produced some messy results, but this was quite an easy one. As you could see, because of a and b, we have taken two variables, which helped us a lot. Okay, so thank you.